All right, so we're finding roots and zeros, and we're using some of the skills that we've learned. And here we're told we're going to use synthetic substitution to find the zeros. And then it says find all of the zeros of the function h of x equals x cubed plus 2x squared plus x plus 18. Well, if first just looking at this function and thinking about what we talked about a few moments ago, Descartes' rule of signs, I don't have any sign changes in this function, so I know I'm not going to have any positive real zeros. And if I were to do h of negative x, let's see, what would I know? Well, I know the sign will change on this. It'd stay the same on this plus 2x. On the plus 9x, that would become a negative. And plus 18 is going to remain the same. So let's see how many sign changes I might have here. 1, 2, 3. So I've either got 3 or 1 negative real zeros. And if I've just got 1 negative real zero, then I could have 2 imaginary zeros. Now I went ahead and graphed this thing, as you see, and it looks like I've got a real zero here at negative 2. And I didn't look at the table because I'm going to use synthetic division or synthetic substitution to prove that negative 2 is actually a real zero. And that'll give me a depressed polynomial because you can see I don't see much of this graph in this thing, probably because of the plus 18 sitting out there, where my y-intercept actually is going to be at 18 and my window setting is set at 10. So let's go ahead and use negative 2. We're going to synthetically divide. We call this using synthetic substitution. And I'm going to write down my coefficients. I got x cubed, x squared, x, so I don't have to put any placeholders in there. So I got 1, 2, 9, 18. I'm going to draw a line. I'm going to bring the 1 down. And let's see, negative 2 times 1 is negative 2. And 2 negative 2 is 0, and negative 2 times 0 is 0, and 9 and 0 is 9, and negative 2 times 9 is negative 18, and shazam, I got a 0 remainder, and therefore negative 2 is really a real 0. Well, now I got this depressed polynomial, which I can now write as x squared. Remember, I go 1 less than where I started, plus 9. Okay, well, let's set this equal to 0. And we're going to subtract 9 from both sides. So now we got x squared equals negative 9. And we're going to take the square root of both sides of this. So now I got the square root of x squared equals plus or minus the square root of negative 9. Well, square root of x squared is just x. And let's see, the square root of negative 9. Well, that's the same as plus or minus the square root of negative 1 times the square root of 9. And the square root of negative 1, what is it? What is it? What is it? It is equal to I, an imaginary number. And what about the square root of 9? Well, the square root of 9 is 3. So then, the square root of negative 9 is 3i. So x is equal to plus or minus 3i. All right, now what are my zeros? Well, I got 1 at negative 2. We proved that with synthetic substitution. And then we used our depressed polynomial and solved it. And now I know I got 1 at 3i. And I've got 1 at negative 3i. 2 zeros that are not going to cross the x-axis, because why? They are imaginary. So use your imagination, and using that along with skill and proving through synthetic substitution, I know that my 3 zeros are negative 2, positive 3i, negative 3i, and guess what? I am done.